Hi, everyone. Thanks for joining us today. I'm Mike Paquette from Elastic, and we are thrilled to introduce ESQL, our exciting new piped query language. We think ESQL is a game-changing capability that will really transform the way you interact with your data in Elastic, allowing you to extract deeper insights from your data and then giving you the information that you and your analysts need to succeed at your missions. And we're very excited to be here today for our panel discussion and demonstrations. In fact, we're going to start off with a very quick introductory demo from James Spiteri to provide some context for the rest of the panel discussion. James, over to you.
Perfect. Thanks, Mike. Hi, everyone. Really excited to be able to demo this for you today. So like Mike said, we'll start off with a very short demo just to give you a really quick glimpse into what we'll be talking about in the panel today. So right now, I am within Elasticsearch, more specifically our timeline view, which is our main way within Elasticsearch for you to hunt and search and run investigations. And you can see I have a pretty short query just for the sake of this short demo here. But I'll just walk you through really quick what it's doing and some of stuff we've never been able to do before we had ESQL. So not only are we searching from a specific log source, but we're also aggregating. So you can see here we're creating a new field and we're aggregating the source bytes, for a user, a process, and a host name. So we can split that. We're doing some math and creating new fields, basically to change between bytes and gigabytes. And we're doing some additional filtering there. We're doing some sorting. And we're also pretty much arranging the results as we need them with the keep command. And this query gives us two outputs. One is a chart, which is great. So right within our hunting experience, we now get charting capabilities, even though I didn't have to specify a charting command there. And you can also see I can edit these charts right within line over here. So if I wanted to change the color scheme or do any of the typical changes that you might be used to when it comes to charts, that's all immediately available in line as you make these changes. And then, of course, we get our table of results at the bottom. And the results are pretty much as we described above. So that was a very short demo, just so you get some context into what we'll be talking about as part of the panel. There are, of course, much more in-depth demos coming up. But for now, I'll hand right back over to Mike.
All right. Thank you, James. Exciting stuff. So now we're going to dive into our panel discussion. So let me introduce our panelists. I'll start with myself. My name is Mike Paquette, and I'm a Senior Director of Product Management on Elasticsearch team. And I'll be the moderator for today's panel. And we are fortunate to be joined today by three guests from Elastic's customer, CDW. We have Harvinder Sandhu, who's a cybersecurity manager. We have Warwick Wan, who's a principal consultant. And we have Yasser Al-Daif, who is a security specialist. So, gentlemen, thank you for joining us today. We look forward to your participation. And rounding out the panel are two of my colleagues from Elastic. I have James Spiteri, who you just heard. James is a director of product management, also on our security team here at Elastic. And we have Henrik Nordvik. Henrik is a principal software engineer on our site reliability engineering team here within Elastic. So welcome all of you to our panel discussion today. James, since you were speaking, I'm going to target my first question at you. First of all, can you tell me how you've been involved in the development of the ESQL language?
Absolutely. So we have a dedicated query languages team at Elastic who were really hard at work putting this together. Earlier on throughout the year, I nominated myself from the security product team to make sure that, listen, whatever we're developing is going to work well for security users. So I got my hands on the query language well in the very beginning, before there was anything that you're going to see today in today's demo. And the reason for doing that, one, not only to make sure we have it captured properly for our security customers, to make sure we're filling the gaps that we need there, but also I wanted to make sure we help when it comes to running our what we called our private beta program. So I was involved in that, where basically we selected a couple of customers where we gave early access to ESQL. So not only do we hear from so the query languages team didn't only hear from the product perspective, but they also heard very early feedback from some of our customers. So I've been very heavily involved. It was a privilege. I found it to be involved so early, and just seeing the development of the language over the last year or so. So that's how I was involved in that, Mike.
That is awesome. So James, let me ask you a different question. So why in 2023 is Elastic introducing the ESQL language?
Yeah, absolutely. So, we've been marketing ourselves as a SIM since 2019 now, and so just about 4 years. We've been in the security arena longer than that because people were using us for the longest time, myself included, ever before we ever had an actual security solution or SIM. However, we've always heard from our customers and our users that they would like more abilities within our query bar. So we had, Elasticsearch has many, many powerful ways of searching and manipulating data. Our detection engine, even before ESQL, had very powerful ways of detecting threats. But what we've heard time and time again is that there's sort of this industry expectation where analysts want to be able to do everything within a single query bar. And when we say everything, we mean not only search, but also manipulate, aggregate, and transform data as they see fit. So that was one reason, we're like, okay, we should definitely invest in this, make sure we keep, or I should say, enable our users to be as efficient as they can be when it comes to searching. So that's why we did this in 2013, mainly as a complement to all the existing, actually 2023, not 2013, mainly as a complement to all our existing ways of working with data that we had today. I would also say that, it was a good opportunity for us within this era of generative AI, where we took advantage of what we've been doing there to really complement like how we present this to our users. So you might see some blogs around how we've built these AI assistants to help you craft queries and then use that as like a natural language input to run these searches. So it was also really good timing there to start doubling down on this initiative.
Excellent, James. And I just have to ask this question. So we think Elastic now has like 9 query languages. What was missing? What makes ESQL stand out from those other languages?
Sure. It's funny. I wouldn't say anything was missing. I would say they were all just completely disjointed. So you could do something in one query language that you couldn't do in another, which didn't give like the best experience. Like you could do some really powerful stuff with each of those individual query languages, but we just didn't have a good way of consolidating that story. So that's where, that was the challenge that really motivated the development of ESQL. Like let's remove that pain point where users have to pivot to a different query language for a different task and just try and bubble everything up into one as much as we can.
That makes a lot of sense. Finally, James, if you bear with me for one more question. I think Elastic is not the first company to introduce a piped query language. What is different about what Elastic brings to the analyst party, if you will, with ESQL, as a piped query language?
Absolutely, Mike. And I think the main difference that we have now as Elastic is users get the best of both worlds. And what I mean by that is for the longest time, and we will still keep advocating this, but we always told our users, do as much transformation as you can on ingest as data's coming in, right? That's good for performance reasons. It's also better when you're crafting detections because a lot of the hard work was done up front. But we all know that there's going to be situations where that's not always possible, or sometimes data makes it into a cluster or an Elastic stack which hasn't been parsed, or during an incident you need to bring on an emergency data source. So now users have the best of both worlds. They have the power of doing rich transformations and enrichments on ingest, and being able to do it at query time now in a scalable way, because we've built not only a new query language, but a whole new compute engine to power ESQL. And I think that's going to be a really, really big difference to how it might be done in some other platforms.
Excellent. Thank you, James. Really appreciate the input. Hey, let's go over. I have some questions now for our CDW team. So again, thanks again for joining us, folks. Warwick, would you be able to provide a little detail on how you and your team have been able to take a look at and use the new ESQL language?
Sure, Mike. Yeah, we are very fortunate to be in the beta program and before the preview release, and we used it in the sandbox that I provide by Elastic. We haven't measured the metrics yet, but the actual UI we have been using it, and it's very fast, and we didn't experience any lagging at all in the search.
That's awesome. So again, no real performance metrics, but the experience has seemed performant. Is that right?
Yeah, it's very performant.
That's excellent, and that goes back, I think, to what James was talking about. This is not just an overlay syntax on top of Elasticsearch, but also is invoking a new compute engine. So that's it's really great to hear that feedback. If I could stay with CDW, a question, maybe Yasser, you could help us with this one. Has there been an opportunity for ESQL to help you and your team better accomplish your goals?
Sure, Mike. Yes. So it helps analysts to speed up the investigations and improve visibilities to the data. So by using ESQL language, to perform data transformations without switching to Lens and switch back to search. And this was really great, like a great addition to the team.
Awesome. Thanks for that. And again, with the CDW team, Harvinder, I had a couple thoughts for you. I know when we talked earlier, you'd mentioned that you've used other SIMs that have piped query languages. First of all, how did you like using that experience? How do you find using those in your past?
So yeah, Mike, I have most of my experience is the Splunk SPL. So in my experience, those are great. So in my opinion, I think this was the missing the piece in Elastic query languages. But now you guys are coming up with the ESQL. I think this fits perfectly, specifically for me. I think that was the gap, and I see it filled with ESQL. So that's amazing.
Excellent. So you were pretty comfortable with as James described, the schema on read approach, right? Is that you felt that flexibility helped you accomplish what you're trying to do?
That is correct. So yeah, that flexibility, schema on read is amazing. As James was saying earlier, it's not always possible to write the data in or parse all the fields correctly at the right time. But now, because we can, parse those fields, maybe even using regex right at the read time. So that's that is really helpful while doing investigations during our, day-to-day use cases.
All right. Yeah. Thank you. That makes a lot of sense. Hey, based on that, what is your expectation about the how Elastic's introduced ESQL both into Kibana and the security solution? Do you see those as both having value in your particular use cases?
That is correct. I think I would if I have to kind of describe in a single word, I would use the consistency. I think that's what was missing. Specifically, if we take an example of Kibana analytics, we were used to use KQL, right? And if we were using as an example like Elasticsearch, even though KQL was present, but most of our security use cases or the alerts were actually written EQL, right? So if we, as an example, we have to investigate further, and we have to kind of try to manipulate that search in terms of KQL, which wasn't possible, right? So now, because the same ESQL query language is present both in Kibana Analytics plus Elasticsearch, I think this is again amazing to me.
Great, thank you for that feedback. Hey, was there any special processes or any difficulties in learning the new ESQL syntax, or anything you want to share from your experience?
Honestly, specifically for me, with the background of being SPL user for so long, for years, transition to ESQL was a natural language. I didn't have to do much of a learning. So for me, it was extremely low learning curve.
Awesome. Well, good. Well, thank you very much for the feedback for our CDW team. Thanks so much for joining. Hey, let's get back to Elastic. Henrik, Warwick and the rest of the team just walked through their ESQL use case for security, but ESQL also can benefit observability use cases. That happens to be an area that you specialize in. Can you share with us some common observability use cases or opportunities to put ESQL to use in a observability function?
Sure, Mike. So as an SRE on the observability team, we do have a lot of data, and we typically dig into those, like for instance, in instant investigations, where typically you haven't prepared a dashboard before because it's a unique situation you haven't seen before. So being able to ad hoc be able to both transform if you if the data wasn't in the exact format that you needed it, and then being able to aggregate and slice it in different ways that you haven't been able to before, at least not easily in the same query as the transform. So like we do a lot of currently we do a lot of like create custom lens visualizations, and then like it's almost enough, you can kind of visualize it, but then there's a one extra step where something's like you need to aggregate on top of that, like you need a summary of the total, and that's been very difficult. Where we had to previously create like Python scripts or something to take it out and then ingest it back and then visualize it. So yeah, and like as I said, we have most of our logs are JSON, so they have like special fields, but some are unparsed. So being able to grok those has been a game changer.
Excellent. Thank you for that, Henrik. I think we'll be hearing from you a little bit more later, with maybe putting a little demonstration together for that. But let's wrap up the panel with one more question for James. James, ESQL is on the scene, introduced in the Elastic platform. What's the future looking like? Is it done? Is ESQL all over? Is there a roadmap? Like, what's the future look like?
Yeah, so we're still scratching the surface, right, with ESQL. So it's far from done. We feel for this release in its tech preview state, users can get very far already. But mainly what we're thinking about next are one additional functionality or functions within the query syntax. Mainly, functions we know users are looking for, which we're going to iteratively add over time. Performance is always key for us, Mike. Making sure that with every release we see what we can do to make performance even better. Not to say that it's not good now, but every single release is like a high priority thing. Let's make sure we see what we can do to make it even better. We have some features we need to work on for like our larger enterprise customers, like cross-cluster search support and some other things there. So it's a very, very bright future for ESQL. We are literally just getting started, which is exciting because there's so much already that users can do, even in our just getting started phase. We'll have a really rich roadmap ahead of us.
Great. Thanks again, James. That's awesome. So I'd like to thank everyone for a great panel discussion. Thank you all for your inputs and feedback. Super informative. Hope our audience is really enjoying this. What we're going to do now is we're going to close down the panel and we're going to dive into the demonstration section of this live stream. So first, James is going to walk us through a security-related demo of ESQL, and then Henrik's going to come back and give us a walkthrough of an observability demo as well. So thanks, panelists. And James, let's take it away.
Thank you, Mike. That was a great panel. So happy to follow up with this demo right now. So what I thought I would do as part of this demo for security is I'd love to walk through a query creation with you. And this is a pretty long, extensive query that you're seeing on the screen. It's following up from the demo I gave previously around, like we were calculating like outbound traffic and that sort of stuff. So I'm actually going to get rid of this query and I'm going to do it line by line with you just to explain what we're going to be doing. So the use case I have here is I need a query that can calculate the amount of traffic that my users might be exfiltrating from our networks on a given day. Specifically, I need to know if there's more than a gigabyte worth of traffic from multiple different hosts for a particular user. Where traditionally this would have taken several different searches within different parts of Elastic, we're able to do this all within a single ESQL query. So I'm going to go dive right in. So firstly, within ESQL, you'll notice there is a primary difference to even how you start the query. You'll notice the first line I have is defining what data view or what index pattern we're going to be searching. Whereas traditionally you would have used a drop-down picker to select your data view. It's now part of the query definition, right? So I have that there. And the first thing I want to do is start filtering for some events. So I'm just going to put in our first pipe statement there, where I'm essentially excluding all traffic which is being made to internal IP ranges, right? And I'm also excluding traffic where there is no autonomous system name associated with. This is something we enrich our data with up front, so I'm able to filter for that very, very easily. So far, you can see if we take a look at our results, nothing too different to what we might be used to, just some basic filtering, and we've now already have around 500 hits. Let's, of course, make this better. So we said we want to be able to calculate this on a day-by-day basis. So I'm going to add in 2 new pipe statements here. And you can see we're using the eval command to create 2 new fields. And we have some functions that allow you to work with date ranges. So in this case, we're basically grabbing that timestamp and we're truncating it down to 1 day. And we're also formatting it to get sort of a nicely formatted sort of year, month, date situation. And like this, we are essentially creating 2 new fields and just manipulating the date so we can have day-by-day buckets, right? So if right now, I'm filtered for a day specifically, but if I filtered for 30 days, 7 days, any results I get would be split on a day-by-day basis, which is a very common thing to do for these situations. Before I run this query as it is, let's start aggregating. So this is really important to be able to run some calculations and aggregations on the data to count the amount of outbound traffic and the number of hosts. So you see here, I'm actually going to run 3 aggregations in one line of ESQL syntax, which is really, really powerful. So we're creating a new field, and we're going to assign that to a field called dest count, which is basically doing a standard count of everything, right? Essentially counting all the outbound connections that are being made. We're doing count distinct, so counting unique host names that are being this traffic is leaving from, right? So remember, my use case here is multiple different hosts on a given day. Obviously, we need to calculate the traffic, so we have a new field here for total bytes, which is doing the sum of the source bytes coming from our data set. And we're going to split all of those aggregations by the user, the process making that connection, the day, which we calculated here, right? So the beauty of pipes, you can pipe different fields that you would have created previously. And again, the autonomous system name. So I'll run this like this, just so you can see sort of what to expect before we carry on. And you can see we already have our results. We have our aggregate counts. We have our fields that are of interest. We have that day-by-day bucket, right? Very, very powerful stuff. But let's make this better. So first of all, I have usernames here. And you can see it's basically real users as well as system users. Right? So basically, any services which are being run by a system, obviously they have service accounts or other real user accounts, as I like to call them. I'm mainly interested in real users making this request. So the way I'm going to do that as part of my query is I'm going to use our enrich command, and I'm going to enrich my username field with an enrich policy I have for users. And essentially within this enrich policy, I have a mapping of if a user is a real user or a system user, basically with some of their Active Directory or LDAP groups. So we can do that. We can run our enrich command. We've also, by the way, created a brand new enrich UI to help you with this. And you can see now I get this new field called group name. And wherever relevant, there's a mapping between a real user and a system user. But now that we've done that, we should probably do some filtering, right? So we can say where we actually have a username always, and the group is not null. So we always have a group and a user associated. and that will take out any situations where we don't have that data. You can see now we have like someone like James Spiteri as a local admin, system as a system user. So now we have that additional context. So enrichment really, really powerful to be able to do there. Let's do some additional calculations, right? So I'm going to add 3 additional statements here. So first thing I need to do is I want to change this byte figure to gigabytes, right? Again, my use case is more than a gigabyte per, across multiple machines. Now, instead of working with bytes, of course, we can make that with some very simple math into gigabytes. First thing I'd need to do is grab that bytes value and make it into a format of a double. And then we can just really simply calculate what gigabytes would be by grabbing that double value that we just used and dividing it by 1024 3 times. And we're also going to round it up to 2 decimal places. So you can see we combined a bunch of different stuff here. And then after we do that, we can filter. So wherever the total gigabytes is greater than 0, right? So we can run that now. And it's going to be really, really helpful. So you can see our total gigabyte value here, which is really, really powerful. Okay, I think it's starting to start cleaning up this query a bit. So we did a lot of work, and now we need to filter down so we can capture our specific use case. So I'm gonna paste in the rest of this query here, and I'll walk you through it. But essentially, I added another eval command with a case statement. Case statements are extremely powerful. So in this case, I want to add a new field called follow-up, where essentially, if we do find that their total gigabyte value is greater than 1, the unique host count is greater or equal to 2, then this follow-up field is going to be given a value of true, which means I need to follow up for this particular user because they're matching my findings for data exfiltration. Otherwise, it's given a default value of false. We're doing some, again, further filtering where we only want the follow-up equals true responses and making sure that the group name is not within system users. So again, real users. We'll sort by the total gigabytes in descending order. We'll limit it to the top 10 results. And then we'll format our output in a way which would work even better for us. So we did a lot of field manipulations. We did a lot of rounding up field creations. So I'm only interested in these fields. So I'll run this like this. And there we go. There's a real value here. Someone called James Spiteri seems to have exfiltrated over 4 gigabytes of data from 2 different machines via process of Chrome to a destination of Google. So this could be something like Google Drive or something like that. They are a local admin, and we should definitely follow up. So that's from a query perspective, right? Look how powerful this is. Something that traditionally would have been pretty complex to do within the various different areas of Elastic security or Elastic in general. But a search like this is only part of the story, right? So this is right now, we've run the search within our timeline. I would like a detection for this now. So I need to get alerted if we do see this. I have a saved query. I should say I have this saved over here. So within the detection rule configuration page, you do have an ESQL rule type now. And I put in a very similar query to what we were just looking at. There's a one-to-one match between what you can search for and what you can query on. What's nice is like I have full control over the output of these fields, right? So now as a user, this is the first time within the detection engine, we've given you full control over sort of what output you get from the detection that you're crafting. I had this set up before, so I'll just show you what some of the results would look like. So you can see our query definition, and then you can see these are some of the findings. So someone, in this case, we created it for more than half a gigabyte, so 500 megs and up. And you can see we get all the relevant fields that we'd need as well. I'll just change this view to sort of a grid view. And so everything is there, everything's available, and you can start crafting these detections as you need. The last thing I'll say before handing over to Henrik is something I alluded to in the beginning, where we're now in this era of generative AI. So what has Elastic done to sort of help with this? So until you learn how to build these sort of ESQL queries, not that it's particularly difficult, but to some of you, it might be a totally new, different concept. We've actually allowed our assistants to be aware of ESQL. So in this case, for example, I used our Elastic AI assistant to give me a query for being able to detect brute force attempts against Azure AD. So very natural language question, and it gave me a fully functional, perfectly crafted ESQL query, assuming that we're using the common schema and Elastic agent, and it also explained what it's doing. So then I can simply copy this, paste it into our detection, and we'll be pretty much good to go. That's what I wanted to show you from my end. I'm going to hand over to Henrik, so he gives you an observability demo. Henrik?
Thank you. Thank you. I'm going to go through a case that we had like a couple weeks ago, where we were looking into basically which hosts were taking the long time to boot up for some reason. So we didn't have any instrumentation, so we were going by basically the logs that we had. And so we found basically in the syslog, we had messages that came that says like the cloud init part of the server bootstrap process took this many seconds, and I wanted to basically query that and create a report. But previously, what we actually did was create a runtime field. We had to have an ingest pipeline and a lot of things. Like it took a long time to actually just grab that value and aggregate on it. So I'm gonna do basically the same thing just in ESQL. So I'm gonna go through how we structure the query. So we're looking for this particular message among all of them, where you start, the message starts with cloud init. Starts with, which filters it down quite a bit. But there's also some messages that are just like kind of in progress, kind of. So it's part of the process, not the actual finishing. So we're looking for messages where the message contains this particular string, like so that's the actual time it took to boot up. And then you can use the really powerful grok processor to actually parse out the number part. So you can grab for a grok, sorry, for a number here, and like this is the same syntax as we had in the logstash pipeline. So use the number to parse a number and give it a name. Bootstrap creation sequence, and that should give you another field that has that value, and it pops up here as an available field. And now it's parse just that part. So now it's currently a string, so you have to convert it to a float or double to be able to actually summarize it. The same. And then we want to see like some kind of stats of the average or average bootstrap time. Average seems to be 400 seconds-ish. And then you can group that by, for instance, host, find this particular host. These all seem similar. You can group by the machine type. We also have the type of the machine. So you can see that some different instance types take slightly longer than others. Like we were seeing like a particular type that was slower. So we basically did that, and then also calculated the maximum. And so some instance types had a lot higher like max duration. So some particular host of this particular type were slower than others. And we've tried to investigate like why that was. And so this query took like 5 minutes to create in ESQL, and took several hours to do like without. So it's been a real-time server. And then another case that we have is like more aggregation of data, like where previously we would use just lens, whatever is available in lens. And there's some limitations that it has, such as we're trying to, let's say, figure out which process, like we have multiple hosts, which process in total uses the most amount of memory, like what's the most expensive process. And previously, we would try to get this from Lens directly, and then basically you have to break down the memory and then by host name to get the average per host, and then also per process per host, which is a pretty big aggregation. And there's limits on how many values you can expand in Lens, because it's doing all these aggregations basically kind of client side, not within Elasticsearch itself. So it has like this will only go up to like 1,000 or a couple thousand before it starts complaining about too many buckets or similar. So basically we want the total here, not this is per process per host, but if you get, so you can do the sum. So it's a sum of an average, which is kind of works, but it doesn't provide the whole picture, especially if you have more than 1,000 hosts. But with ESQL, this is basically the same query, like average process memory per host, and then sum of that, and then convert to gigabytes, and then sorted. Now you can notice that it's actually sorted. This one is actually not, because it does the sorting before it does the group by. And this one, so this one gives more correct picture, and is able to do, well, it doesn't have the same limitations. And then you can also group by various different other ways to find like the most expensive host, or like the most highest memory usage on each host, by changing just the group by. So yeah, that's my demo. Back to Mike.
All right. Thanks, Henrik and James. And with those demos, our live event is concluded. So special thanks to Warwick, Yasser, and Harvinder from CDW for joining us for our panel discussion today. And for those that attended, if you'd like to get piping with ESQL yourself, check out the links in our chat. We've got for a free trial an Elastic Cloud, a visit to our ESQL webpage, or a quick look at ESQL in our public demo. Thanks again for joining, everyone. See you next time.